Hello everyone and welcome back to another VASAviation video. Today I want to talk about a topic that has been quite controversial on the Cessna citation accident that occurred a couple days ago in San Diego. I've read many comments in my video, social media, other videos, and also some YouTubers that used to do this kind of analysis or commentary on incidents and accidents, saying that this pilot was shooting this approach illegally because his aircraft was not authorized to do so. Because the approach, if we look at the approach plate for the RNAV 28 right at Montgomery, San Diego, we can see the approach is not authorized for category C and D airplanes. The thing is that the Cessna Citation 550 is a category B. So yes, he was indeed authorized to do this approach. So in this video, I'm gonna try to explain, especially for those that got this thing wrong or maybe don't know what this is, the approach categories and how we calculate and how we know which approach category we are or our airplane is. Okay, so first of all, we're gonna talk about what the approach categories are. So depending on what approach category your airplane is, you're going to choose some parameters during your approach, especially the minimums. The higher your approach speed is, the higher your minimums are going to be. We have 4 or maybe 5, but let's say we have 4 approach categories. So if our landing speed, which I will talk about here in a second, if our landing speed is 90 knots or less, our approach category will be A or Alpha. If the landing speed is between 91 and 120 included, our approach category will be B, Bravo. If our landing speed is between 121 and 140 knots, our approach category will be C, Charlie. And if our landing speed is between 141 and 165, our approach category will be D, or Delta. So before we get into the detail of this, just imagine Category A is for Cessna 172 Piper Cherokee small prop or small piston planes. The Category B is for small private corporate jets or bigger prop planes like the Beechcraft or these kind of bigger airplanes, turboprop airplanes. Category C is for medium-sized airliners like Airbus A320 or Boeing 737. And the category D is for even bigger airliners such as Boeing 747, A330, Boeing 777, etc. So now that we know the approach categories, different approach categories, how do we know the landing speed? So for small airplanes, since we don't have a reference speed, we use the VAT, and that is the speed over the threshold, the speed at threshold, VAT. And that is 1.3 times the stall speed of the aircraft at maximum landing weight in the landing configuration. Now for bigger airplanes, we will add another term, which is the VREF, the reference speed for landing, which is exactly the same as the VAT, except that the terminology is different. Now the VAT or the VREF is the airspeed, the slowest airspeed that we can maintain and we have to achieve right over the threshold. So when just imagine the threshold is the numbers of the runway, that is the threshold, and that is the slowest airspeed that we can maintain. We can fly faster than that airspeed, but never slower than that airspeed, except when we are preparing for the flare, we are over the threshold. At that point, we are at VREF speed. We pull the power all the way back and we start our landing and touchdown. We flare and we touch down. Never during the approach you can go lower than your VREF. Now in this type of airplanes, we're obviously heavier than just a basic Cessna 172, and also we have a wider weight range. So we need to calculate the VREF depending on our current weight for this landing. You can see here that this table, this diagram here is for the model 550, so it's for the Cessna 550. This screenshot has been extracted directly from Cessna and the AFM or of the Cessna 550. The AFM is the Aircraft Flight Manual. This is the performance table for landing. We can see the configuration is flaps full at sea level. Montgomery is 400 feet, but there is no difference. Trust me, there is no difference between sea level and 1,000 feet altitude elevation. So we have two tables on the left, on the right, and we have two parameters that are different on top. The weight. So we have a weight on the left, which is 14,800 pounds, and we have a weight on the right, which is 13,500 pounds. Now, on the left side, there is an asterisk, and I will go through that just in a moment, because 14,800 pounds is the maximum takeoff weight of this aircraft. Now, on the right side, the 13,500 pounds is the maximum landing weight of this aircraft. Now, the asterisk on the left side is because this is only to be used in case of an emergency, because if our maximum landing weight is 13,500 pounds, obviously we cannot land with 14,800 pounds, except in an emergency takeoff. So just imagine you are taking off, and on the takeoff you have a dual engine failure or some other catastrophic emergency that requires an immediate landing, and you have just departed with 14,800, which is your maximum takeoff weight. You can land in that case using this performance table. Now, for the purpose that we are looking for, we're just going through the right side of the table. In the case we're landing at our maximum landing weight on this aircraft of 13,500 pounds gross weight, so the whole aircraft weighs 13,500 pounds. If that is the case, we have that the VREF for this aircraft is 111 knots. Remember, category B fits between 91 knots and 120 knots. So yes, this aircraft is category B. Some of you may ask about the VAP, which is 118 knots. The VAP is the approach speed. You can fly this approach speed, and this is a little higher airspeed to correct for gusty winds, turbulence, or any other stuff. But again, your speed over the threshold for landing should be VREF, and that is the airspeed that the approach categories are based on, the VREF. Now imagine we're on a takeoff on our maximum takeoff weight, we have a catastrophic emergency, and we need to return back to land. Even with maximum takeoff weight, our VREF is higher, of course, but it's 117. Even at that point, and in that situation, we are still falling into category B and not C. Our VAP, however, is higher than 120 knots, but VAP is not what the approach categories are based on. It's VREF. So even in this situation, of course, the VREF is higher because we are heavier and we need more airspeed in order to not stall the aircraft. But even in that situation, even though the VAP is higher than 120, I don't care about the VAP for this purpose. The VREF is between 91 and 120, so we are category B. Now let me show you, however, another example. This is the landing performance table for the aircraft that I fly, which is the, let me change this, which is the 560 XL. It is another model, completely different model from the 550. We are heavier, and we have heavier and higher takeoff and landing weights and speeds as well. So if we go to the right side of the table again, we have 18,700 pounds. That's our maximum landing weight on the XLS. Our VREF is 117. Our VAP is 124. Again, if we're landing maximum landing weight on the Cessna XLS Citation, we're still falling into the category B. However, what happens if we are on a maximum takeoff weight, we depart, we have a catastrophic emergency, and we need to land back? If we go to the VREF, now our VREF is 122. So only in case of a catastrophic emergency and we need to land back at the airport with maximum takeoff weight, which is the maximum takeoff weight you can take to the air. You cannot take any more. You can take more fuel on the ground, but you cannot take any more weight to the air. This is the maximum weight that your aircraft can fly with. So only in that case, and we need to return to land, our VREF will fall into the category C. I don't know if in that situation we will take any minimums to category C, or we will just, of course, go ahead and land right away. But just so you can see the difference between both airplanes, only in an emergency situation we would fall into the category C on a Cessna Citation XLS. And now that we know how to do it on the papers and on the documents, on the manuals, the theoretical part, let's do it on the practical. This is a video from a few hours ago. I am loading the arrival to destination. We are coming back to Spain, to Madrid International after a few days in London. And I'm loading up the arrival and the approach, transitions, and everything. Now that the FMS knows what arrival we're flying, what approach we're going to fly, or at least what approach we're expecting to fly, we can go to the approach performance page. We have learned how to calculate the VREF based on the performance tables on the manuals, but of course now electronically we can do it even more precisely. The tables are just some numbers, and sometimes you have to interpolate between both values, and then you lose some precision there. So we go to the approach performance page, we see the airport, and we see the runway that we are expecting. The runway wind will calculate the wind component, tailwind, headwind, left or right. The runway length, of course, is in the database of the FMS. The runway slope, we can select dry or wet, and then we can input the wind, the temperature, and the altimeter or QNH setting, the pressure setting. The next page, we have the anti-ice. We can land with the anti-ice off or on. We have the landing weight, which is what the FMS is calculating that the landing weight will be when we get to the runway. We have the gross weight, which is the weight we have right now at this precise moment, and we have the maximum landing weight. Then we have the landing field length and the runway length. So the FMS calculates how much runway we are going to use during the landing and the rollout. And then we have the landing factor that we can add for safety reasons. Per company SOP, we usually, if we're flying commercially, we use 1.7, and you can see how the landing field length changes. So the more safety margin or factor you apply, the longer your landing field length is going to be. With all this information, you have realized that on the right side of this page, we have the VREF and the VAP. This is automatically calculated by the FMS. After double checking that this information is right, those values look very good to me, we can click on the send button, so we send those airspeed to the PFD in front of both pilots, so we have those airspeeds displayed on the screen in front of us so we can see them. In the third page of the FMS, again, we have some weights and some limits, some reminders of what we're going to expect during the landing. If for any reasons we want to recalculate or we want to modify these values, we can do it manually. Just because we have calculated other values, other sources, and we want to be more conservative, or for safety reasons or whatever, we can manually change the VREF and the VAP manually. So I really hope this was helpful. Now you know about the VREF and now you know about the approach categories. The Cessna Citation 550 is, by all means, a Category B, Category Bravo aircraft. So if you want me to go through any other details of any other aviation related topic, please let me know. I will try to, and thank you very much for watching.